Let's look at a triple integral in cylindrical coordinates. Here we want to just practice the technique of utilizing the cylindrical coordinates in a triple integral. Notice in this triple integral we have the theta limits 0 to 2 pi, the r limits 0 to 2 root 3, and the z limits r squared minus 3 to 9. Now of course the integrals here and here, that is the r integral and the theta integral, are interrelated. So we work those together, but the theta integral, there's no dependence here on theta, so we can just move the theta integral off to the left. Notice here, for the z integral, there are no z's here. Everything relative to z is constant, so we're just going to get a 9 minus r squared minus 3. So upon integration, we get this. And so first, we look at this integral, very simple. We get 2 pi. And then when we simplify, the minus minus gives us the plus. So we have 3 plus 9, which is 12. 12 minus r squared, r dr. So again, we look at that and say, well, that's a nice u du type setup. We just have to adjust it so it will work. So now, of course, if this is our u, we get a negative 2r, which we don't have here. So we will put in the negative 2 and then adjust for it. And so now this is ready to go. U du, add 1, divide by the new power. Now, of course, what we'll notice here is that these 2's will absorb and leave us with a negative pi. And then when we anti-differentiate, we just get 12 minus r squared quantity squared divided by 2, evaluated between 0 and 2 root 3. And so now it's just a matter of substituting everything. So notice here, when we square this number, we get a 4 times the 3, which we have here. And of course, when we put in 0, we just get 12 squared. And now, of course, 12 minus 12 is 0. And now we have minus 12 squared, which we can write as negative 12 times 12. Of course, one of the 2's will absorb into the 12 to give us 6. The 2 negatives absorb, and we get 6 times 12, which is 72. So our integral is 72 pi, and we are done.